This is Dr. Carroll. Today's video is about polymorphism. Polymorphism is derived from a Greek word meaning many forms, and we're going to see that as it plays out how the compiler can use many forms. Object-oriented programming supports polymorphism. So before we get into polymorphism, we need to explain static binding. Static binding is also known as early binding. The appropriate version of a method is determined at compilation time. So let's look at an example. Here we have our mammal and dog example once again. In the driver code here, notice we're doing something a little different. We have an animal, a mammal object named animal, and a dog object named my dog. We've done that before. But notice now we have a mammal pointer, and we're assigning it to a mammal type. That's fine. We've done that many times before. But notice what we have here where the breakpoint is. We have a mammal pointer that gets the address of a dog object. Now a dog is a mammal, so we can use it in places where we can use a mammal. For example, if you had a subroutine that took an argument as a mammal, we could pass it a dog. Now we can only treat it like a mammal, but this is valid and it'll run. Let's see it. So here we have the code. Let's see what happens. Let's step over it. It took it. It assigned it. We can see that it has a valid address here. Okay, so now let's step over. Let's step into the mammal call to speak using a pointer. And sure enough, here it is. We're calling the mammal speak, and it prints out mammal is speaking. Okay. And now let's see what happens when we step in here. Notice it calls the mammal method because we have static binding. At compilation, it determined that we should call the mammal object here. And so, and that's what we got. Okay? So this worked because we can treat a dog as a mammal because a dog is a mammal. And so we can have that assignment as shown here. Note that a mammal is not a dog, at least not in the program. So we can't say something like a dog pointer getting the animal object. That would not compile. We can do it, but we have to do a cast and cast it as a dog explicitly. So that's static binding, and that happens at compilation time. In contrast to that, there's dynamic binding, where the appropriate version of method is determined at runtime, at execution time. This is also known as late binding as well. Another way to think of this is that the object is going to determine what operation is going to happen at execution time, at runtime. So we can say some methods are called polymorphic methods, and for those methods, we determine at execution time which method is being called based on the object it's being called from. With a static binding, it was whatever it was declared as. For example, the dog being saved to a mammal pointer, it said, oh, it's a mammal pointer. But with dynamic binding, we're going to be able to change that. Okay? C++ supports polymorphism by using dynamic binding and using virtual member functions. What's a virtual member functions? Oh, I'm getting a little ahead of myself. It also extends polymorphism to allow pointers to base classes to be assigned to derived class objects. We'll see that in just a little bit. So virtual methods. Virtual is a key word. So starting out, virtual methods can be overridden. So to make a method virtual, we just put the keyword virtual before its prototype. Let's see the syntax here. Notice we have the word virtual appearing before the return type, function name, and the parameter list here. So now let's change example 3 to be a virtual method. So we up here in mammal, we're going to change it, and all we do is we put virtual right here. Virtual. Oh good, it's blue, it's a keyword. Let's see if it builds. Yes, we want to stop debugging, thank you. I'm going to assume that worked. I closed that window. Okay, here we can see its execution. It compiled, yay. Okay, now let's step over. Okay, we assign that. Dog pointer is set to that. And now if we step over, mammal is speaking, great, step over. Now let's step into and see if it worked. And it worked, yep. We're in the dog class. Notice we're calling the dog speak instead of the mammal speak. It worked. That was our goal, is that we would call the dog pointer. Notice that was determined at runtime and not what its type was. Its type is a mammal pointer, but we were able to call the dog speak method. And that is polymorphism. Here we have that. So to illustrate this again, imagine if we had in the driver code in main this line here, that a mammal pointer to an unknown mammal, and it gets assigned some random mammal. Could be a cat, an elephant, a platypus, and then in the next line we're calling speak on it. So which speak method is called? Well, it's going to be whatever the derived class type is, the cat, the elephant, the platypus. And that's going to be the speak method called if, because speak is virtual. And that's the key point. Speak is virtual. And so it determines at runtime what it should be. Now, a method in a derived class can override a virtual method in the base class. And it only makes sense, really, to have virtual methods in the base class. The two classes must have the same signatures, the same name and arguments. And this is similar to redefining the method. Note, a derived class does not have to override an inherited virtual method, but it can if it wants to. We're given that flexibility. Generally, with all base class methods, make them virtual so that anybody that does inherit can override them, unless you don't want them to be overridden in the future. So let's talk about some rules here. There's lots of rules with inheritance and polymorphism. One, constructors cannot be virtual. Why? I'll let you think about that and come up with a good answer for that. Another rule is if any function in a class is virtual, then it's good practice to make the destructor virtual as well. This allows the derived classes to deallocate their memory properly. Okay, let's see an illustration of this. If we have a base class here with one or more virtual methods, notice the destructor for the base class does really nothing. And then we have a derived class which inherits publicly from the base class, and it has methods that allocate memory. And it has its own destructor because we're going to clean it up. But notice the destructor in the base class is not virtual. So now we have this code, a base pointer. We're doing a polymorphism here. And we're going to call a new derived method and assign it to the base pointer b. And then we use it. And then when we delete b, whose destructor is going to be called? When we call delete b, it's going to go to the base destructor because it was not virtual. Had it been virtual, we would have then gone to the derived destructor and called that appropriately. So that creates a problem because the base might not know how the derived class allocates its memory and won't be able to clean it up. Do remember that a class destructor must be defined when a class allocates memory just to clean up appropriately, right? We always clean up after our messes, right? Okay, more rules. Virtual method magic only happens on pointers and references. Otherwise, we can't be changing the type of a object, of a variable. Another rule is if the base class has an overloaded member method and the derived class overrides that method, then all base class methods with that name are hidden. Okay, that was a little confusing. Let's see an example. So if in our classic now mammal class, we had a virtual speak method, but then we added a speak int method, because we've overloaded speak in the base class, then we're not going to be able to see speak int in the derived class. Well, let's see that example. Here we go with that example. We have a my dog object and a mammal object. And what we're trying to do is we're focusing on speak and see if we can see what happens when in mammal we have our virtual speak, but then we've added this speak that takes an integer, and in dog we just overrode speak, but notice we have no speak, up here we have no speak that takes an integer. So notice I've commented this out here. This won't compile. It can't call that because there's no pointers or references here. This can't be a polymorphic method. But notice we can call it this way. And when we get here, if we step into it, notice we're calling the mammal speak and having it print that. And we can, of course, call it from animal, but we can't call it this way. It won't compile. We have to reference it explicitly using the base class. Okay. There's 4 essential ingredients to call a polymorphic method, and one, you have to have inheritance. Otherwise, you can't have a base and a derived class. You have to have a virtual method, and that's going to be in the base class. And the virtual method must be overridden in a derived class, or we're not going to have this dynamic choosing of which one. And lastly, we have to have a pointer or reference to the base class type, but having that pointing or reference to a derived class. If you have all 4 of these ingredients, then you can have a polymorphic method. That's it for today.